Welcome to Bahamian Mathematics. Today we're going to be having some fun drawing the lines of symmetry in various letters of the alphabet and shapes. This will divide them into equal parts. We'll see how many lines of symmetry we can draw in the letters of the alphabet. Let's take a look. Imagine first, though, a mirror. And if you looked into the mirror, you would probably see a reflection of yourself, just like what's on the screen now. And here's the object, you standing in front of the mirror, and the item in the mirror is called the image. And this is a reflection, and if we drew a line down the middle, you would notice that each is the same. It's just an opposite reflection of what is in front of the mirror. What do you notice about the object in the image? You can see that it's almost identical. He's wearing a hat. He has his hand up to his head. He has a magnifying glass, 2 legs, shoes. Everything is basically the same. It's only that it has flipped. It has reflected. And if we drew an imaginary line, it would be identical on either side. It's in the opposite direction, and it's equal distance from the mirror. You know this as a reflection. This is also a line of symmetry. And in this case, he is standing in front of the mirror a distance away, and the same distance carries him to the image of himself. Now, when we look at line symmetry, it divides a shape into 2 equal parts. And we're going to look at the letters of the alphabet first. Here is the letter A. A line of symmetry, if we can draw one, when we draw it, it will cut the shape into 2 equal parts such that the left looks like the right or the top looks like the bottom. And so if we take a pair of scissors and we imagine cutting it in half somewhere, how can we draw that so that it gets divided into 2 equal parts? If we cut it like this, we'll notice that if we expand it, the top doesn't look like the bottom doesn't look like the top. And so therefore this is not 2 equal parts, it's not a line of symmetry. If we looked in the mirror, the top would look different from the bottom. So this is not equal. So let's try it again with the letter A. Instead of going from left to right, we're going to take it and cut it down the middle from top to bottom, bottom to top, separate it. And we can see now that the left looks like the right, but it's only a reflection of the left, imagining that the middle is a mirror. And so this is a line of symmetry. It is a reflection of itself. And so we say this letter A has 1 line of symmetry. Let's go to the letter B. If we take the scissors and we cut it in half this way, again we can see the left doesn't look like the right, so this is not a line of symmetry. What about if we take the B and we go from left to right and we expand it? Now the top looks like the bottom, a mirrored image of itself, and therefore yes, this is a line of symmetry. It has 1 line of symmetry. Let's go to the letter C. We can see by now that if we drew a line this way and cut it, it would divide that again into 2 equal parts that look like a reflection of itself, and that is a line of symmetry. Going to D, by now we can see that we have to draw the line from left to right. If we expand it, the top looks like the bottom, and this looks like a reflection of itself. If we folded it along the line, each would map onto each other perfectly. So this is a line of symmetry. D has 1 line of symmetry. Going to E, by now you can see this is the line of symmetry from left to right. If we expand it, the top is a reflection of the bottom. If we folded it, imagining if it was a piece of paper, it would fold onto each other. This is a line of symmetry. It has 1. What about F? If we drew the line of symmetry this way, like we did the letter E, and we expanded it, we can see that the top doesn't quite look like the bottom. And in order for there to be a line of symmetry, it has to look equal, an equal reflection of itself. So this is not a line of symmetry if we go in this direction. What about if we went this direction, top to bottom, and we expanded it? Again, we can see that the left doesn't look like the right. And so this also is not a line of symmetry. It means the letter F has 0 lines of symmetry. How about G? This way, when we cut it and expand it, the top looks different from the bottom. And if we try it the other direction and we expand it, the left doesn't look like the right. And so G also is a letter with no lines of symmetry. How about H? Now just from looking at it, you can probably see that if we went this direction from left to right, if we drew a line this way and we expanded it, the top looks like the bottom. If we folded it, it would fold onto each other. So yes, that's one line of symmetry, but let's test out the other direction now. If we went from top to bottom and we expanded it, the left looks like the right. If we folded it in half, it looks like a reflection, so that also is a line of symmetry. So H has two lines of symmetry. What about I? If you stop for a second, you can see that I is almost a turned version of H. And so this probably will have two lines of symmetry as well. Let's test it out. From left to right, it looks like that's a reflection of each other. So that is a line of symmetry. And if we went from top to bottom and we expanded it, we can see the left looks like the right if we folded it. And so therefore that is also a line of symmetry. The letter I has two. What about J? If we drew the line of symmetry in this direction, we can see that the top doesn't look like the bottom, and so that is not a line of symmetry. And drawing it from top to bottom, again, the left doesn't look like the right, and so that is not a line of symmetry. J has 0 lines of symmetry. Now let's take each letter from K onwards and see if we can identify quickly where the line of symmetry or lines of symmetry will fall. In K, we can see that if we drew a line this way, left to right, the top looks like the bottom, and so that's one line of symmetry. If we drew the line from top to bottom, we can see the left would not look like the right, and so that is not a line. So it has one line of symmetry. L, if we tried this way, that doesn't look like that will work. This way does not work either, and so L has 0 lines of symmetry. M, you can probably see that it looks like two people holding hands almost, and so if you went in this direction and you cut it in half, that would be the only line of symmetry that exists in M. So it has 1. How about N? If we went this way, it doesn't look like it would be 2 equal parts, and even this way, it doesn't look like 2 equal parts, so N has 0 lines of symmetry. O. Now in O, if we went left to right, we can see that's a line of symmetry because the top is a reflection of the bottom. And if we went this way, top to bottom, we can see that the left looks like the right, a true reflection. And so that's another line of symmetry, so that has 2. How about P? Left to right, the top doesn't look like the bottom. Up and down, the left doesn't look like the right, so that has 0. What about Q? Q is a strange letter, and you probably will guess that that doesn't have any lines of symmetry because of the little tail at the bottom. Let's try left to right. There's a tail at the bottom. The top doesn't have a tail. Top to bottom, same kind of thing. So Q has 0. R. Let's try left to right. The top has a curve. The bottom doesn't. Top to bottom, the left doesn't look like the right. So R also has 0 lines of symmetry. S. You may be tempted to say maybe that has 1 through the middle. Let's go this way, left to right. But we can see that there's a curve on the top, and if we folded that in half, it wouldn't match with a curve at the bottom. Top to bottom, again, there's a curve at the left, but not at the right at the top. And so S has 0 lines of symmetry. T. You probably can guess that if we went top to bottom and we pulled that apart, that would be a reflection of each other, and so T has 1. U, again, that's similar to T. If we went from top to bottom, the left would look like the right, and so U also has 1. V kind of looks like U. Again, top to bottom, that would split that in half, 2 equal parts, and so V has 1. Now let's go to W. W looks like 2 V's, and again, if we went from top to bottom, the left would look like the right, and so W has 1. What about X? If we went left to right, that looks like that's a reflection, and if we went top to bottom, also a reflection, and so X has 2 lines of symmetry. Y, we can see if we went top to bottom, that would split it in half, 2 equal parts, and that is 1 line of symmetry. And finally Z, if we try left to right, it doesn't look equal. We tried top to bottom, again, doesn't look equal, so Z has 0 lines of symmetry. Now what happens when we look at an equilateral triangle? That means that every side is the same length. 3 equal sides and 3 equal angles. Perhaps we can see that if we start at the very top and came down through the middle, that could cut that in half. That's one line of symmetry. Here's one half, here's another half. So that's one line of symmetry so far. What about if we started at this point and went all the way across, cutting that in half also? Here's one, and here's 2 equal parts, so that's also a line of symmetry. And by now you've guessed, with 3 equal sides and 3 equal angles, if we started here, we also can create another line of symmetry. Here's one equal side, here's another equal side. And so this has 3 lines of symmetry because it is an equilateral triangle. And if you want to see more videos just like this one, make sure that you subscribe, like, and share to the Bahamian Mathematics YouTube channel. And now it's quiz time. How many lines of symmetry and where are they in the following shape? T. Time's up. The answer is 1, and it goes from top to bottom. Number 2. How many lines of symmetry are there in the letter K? Time's up. If you remember from earlier on, we said K has 1 line of symmetry, goes from left to right. Question 3. This is an isosceles triangle, which means it only has 2 equal sides. How many lines of symmetry are there? Time's up. The answer is 1. And here it is from top to bottom, 1 line of symmetry. Question 4. This is a rectangle. How many lines of symmetry do you think it has? Time's up. Did you say 2? You would be right. From top to bottom, it divides it into 2 equal parts. And then also from left to right, into 2 equal parts. You may have said maybe the diagonals are equal, but if you cut them down the diagonal, they won't fold properly onto each other. And so rectangles have 2 lines of symmetry. Last question. Question 5. How many lines of symmetry are there in the letter L? Time's up. Did you remember? The L has 0 lines of symmetry. And now you've solved the mystery of how to draw lines of symmetry in letters of the alphabet and various shapes. Well done.